So here is this alligator, and I'm going to show you how to make it move using inverse kinematics, which is difficult to set up but easier to animate than any other way. Just note ahead of time that every character is different, so I'm going to walk you through how to rig this character, but there may be some slight nuances that are different in yours. So let me know if that's the case. So let me delete all this so we can start from scratch. So here's our alligator, naked as the day it was born. No rigs anywhere. All the pieces separate, nothing making sense, everything difficult to animate. So we're going to apply inverse kinematics to it to make it work. So you'll recall that inverse kinematics uses a special plugin called DUIK, which you have to download and install. But once you've installed it, it's in this window menu up here. And clicking it opens this little tiny window which has all your all the things you need to do inverse kinematics on the object. So you'll recall the first step is to create puppet pins at the joints for our layer. So let's do this quickly on one particular arm of the layer. I'll do his front arm, and I'm creating 3 pins, one for the shoulder, one for the elbow, and one for the hand. And these let you bend that layer like rubber. So the first thing I always do, and you unfortunately need to always do, is you need to name each puppet pin, because this plugin DUIK gets confused when multiple puppet pins have the same name. So try to name them specifically. I'll name this front hand. I'll call this front elbow, and I'll call this front shoulder. Okay. The second thing we have to do is these puppet pins, as you can see, they exist on an effect inside of the front arm layer, and in order for After Effects to do the correct math on them, it needs to do the math on actual physical layers in the timeline. So we need to convert these puppet pins to physical layers in the timeline, which is something that the DUIK plugin calls bones. So if you select the puppet pins and then click the bones button, it will create 3 physical layers that correlate to the puppet pins on the arm. So now we have this hand bone, and if we move that, it will move the puppet pin. And now I'm going to create a controller. So the controller is what we're going to actually use to move and bend the arm. And you generally want to move and bend the arm from the hand, because that's where he'll be picking stuff up from. So I'm selecting the hand bone, and I'm clicking this controller button here in the DUIK window. And it gives us a bunch of arbitrary options that I don't care about. I'm just going to put create, and you can see our hand bone right there. And at the moment, nothing really has been done. We still need to apply the math, and this is particular. We're applying the magical trigonometry that makes the joints bend in a realistic way. And in order to do this, you have to do it in DUIK's rather finicky method. You need to select the bones in order from end to base, meaning from hand to shoulder, and then you need to select the controller. So I'm selecting the front hand, front elbow, front shoulder, and then I'm selecting the controller, and then I'm clicking this IK button. There are 2 types of IK, but I generally use this 2-layer IK and goal. Click create, and we've done the math. Now you'll see when we move this controller, the hand bends in a realistic way. So I'm going to do the same thing for the back arm really quick. Good, now both hands are moving. So now I'm going to do the same thing for the leg. I'm going to create a bone for the foot, for the knee, and for the waist, and then I'm going to name them. Front foot, front knee, front waist. And then I'm going to select them and create bones. And then I'm going to create a controller at the foot. And then I'm going to select them. And you'll recall you need to select them from end to base. So I'm selecting the foot first, which is the end, then the knee, and then the base, the waist. And then I'm selecting the controller, and then I'm clicking IK and creating an IK. So now you'll see off the bat our foot is bending. I'm going to do the same thing for the other foot really quick. And now we have both arms and both legs rigged according to inverse kinematics. So the rest of this will be involved with making the whole entire character move as one, all the different limbs. And this will be different for different characters. So take this more as guidelines for which to be adapted rather than explicit instructions. It takes a while to wrap your head around how this is working in order to adapt it to your own puppet. That's why this is fairly difficult. But hopefully rigging this puppet will give you a sense of how I go about that. So I'm going to create an inverse kinematic set for the spine as well. So I'll do that on the torso layer. So for the spine, I'm going to create a puppet pin at the character's waist, at his middle back, and at his neck. I'm going to label them as such. And I'm going to create bones for them. Here, I expect the neck to be the part which I'm going to have the most control over. So I'm going to create a controller for the neck. And then I'm going to create the IK by selecting first the neck bone, then the middle back bone, then the waist bone, and the neck controller, and creating an IK. So in this case, you can see the spine bending. So a couple problems here. First is that I suppose the tail is going nuts. So I'm going to apply more puppet pins just to that part of the tail so that they'll more or less stay in place. Okay, that helps enough. So you can see when we move the neck of this, obviously the character comes apart. So now begins the process of parenting things to other things so that the character makes sense. So let's see, the first problem I see is that when I move the neck, the head doesn't stick to the neck. That's pretty easy. Let's just take the head and make its parent the neck controller. So now when we move the neck controller, the head will go with it. I'm going to do the same thing for the character's shoulders. You can see that the arms detach when I move the torso. So I'm going to take these two shoulder bones here, front shoulder and back shoulder, and I'm going to make their parent be the bone that's closest to them. In this case, it's that middle backbone right there, you can see. I'm going to parent these guys to that middle backbone. So I'm selecting them, and I'm making their parent the middle back. Now when I move the neck, the arms should move with it. Good, as they do. I'm going to do a similar thing to the waist. I'm going to parent the two leg joints to this lower back pin. So I'm selecting both leg joints. There's the back waist and the front waist, and I'm allowing their parent to be the waist pin here. So now if I move the character's waist, the legs will go with it. So one final step that I almost always do is create a master controller that moves the whole gator except for its feet. And I use that in order to make the character walk. The idea being we can move the whole gator, but its feet stay stuck to the ground, so I can have the feet move according to where the gator needs to be. So to do that, I'm going to create what's called a null object, which is a type of layer. So you can find it under Layer, New, Null Object. And basically what that is an invisible object that does nothing but control other objects. It can be apparent, but it doesn't show up on screen at all when you render. So if you click a null object, you'll see a red square. That indicates the null, but when you render it, when you save your QuickTime movie, it won't be there. So I'm going to take everything that doesn't have a parent, except for the feet, and I'm going to parent that to the null object. So in that case, I'm going to grab the neck, both hand bones, front hand and back hand, and then also the character's waist. And I'm going to parent them to the master. And unless I forgot something, that should move everything. Good, it does. So one more step, you can see when I move the master, the tail stays in place. I'd like for the tail to go with it. Like I said, everything should go with this master except for the feet, so that I can make it walk. So in order to parent the rest of the tail puppet pins, you can see there are these two puppet pins down here that fix the tail to the ground. We need to create bones for those pins because we can't parent the puppet pins as they are. They need to be physical layers. So I'm going to select them, and then I'm going to create bones. And I'm going to parent those bones to the master controller. And so now we have a fully animatable lizard. So the trick to making him move would just be to animate this master going across the screen and then keyframing his little feet controller so that they make sense with the walk. So that's it. Like I said, this will be slightly different depending on what type of character you have. So if you're running into any trouble, let me know and I can consult. That's it.